my name is Anne, metric number 63106, and I'm going to talk about fish migration. So what is migration? Migration does not only involve fishes, but it involves a lot of animals, for example birds, as we all know. Also, if we have watched cartoons like Ice Age, they actually migrate when it's winter to find food or shelter. So let's talk about fish. Fish migrate from a certain place to another place when they want to reproduce, when they want to grow, or when they want to find food. So for example, like salmon, which are anadromous, they grow in estuaries, freshwater, and then they will move to saline water to grow and come back to their original birthplace, which is freshwater, to spawn. So talking about salmon, fishes like these, they can actually travel up to 3,000 kilometers, which is further than the distance of Mexico to Canada, just to migrate. This is amazing. But why do we care about fish migration? We need to, as a scientist, we need to understand how fishes move so that we know and we can conserve the areas of habitats that these fishes move, to preserve the number of fishes so that humans do not overfish, overcatch, or destroy their habitats, because these are where the fishes grow and spawn. Sometimes, as we all know, like structures like dams or any ecotourism buildings that they build up will prevent these fishes from migrating and finding food, and therefore they will just die and not be able to reproduce. Why and how do we tag these fishes? For example, like our cats and dogs at home, we put them on a collar so that, or like sometimes they will put a tag on them where we can locate just in case our pets go missing. So for fishes, there are a certain evolved way that we can actually tag these fishes by using GPS, which is Global Positioning System. Humans are always curious about where do the animals go. For example, if birds, they will put a small plastic tags around their legs so that we can determine where do the birds fly after a certain season, where do the birds stop and breed. For smaller fishes, it is a bit hard to tag because their bodies are slender and small, and it can be easily carried away by the currents. But for bigger fishes, there's a certain tag that you can either tag, maybe for sharks you can tag at the dorsal fin, or for turtles there's a pit tag at their shell, where you can locate where do these turtles lay eggs by the beaches. But there's a natural way where scientists can actually determine where do these fishes go, especially for the migration part. So for fishes, they have this natural tag which is called the otoliths, or the ear stones inside their body, where chemical reactions are produced in the water. Scientists can actually detect the chemical reaction between this water to know where the fishes go, what do they eat, their habitats, because the tags are different. These otoliths are different in different habitats, which is the estuarine, saline water, and freshwater. So for example, these otoliths are like tree barks. As an example, tree barks contain rings where you can determine the age of the tree. It also happens in otoliths. You can look under this in microscope, where you can see rings around the otoliths, and you can determine the age and basically everything that we need to know about fish. Fish with skeleton, this is an extra information. Fish with skeleton or cartilaginous fish like sharks, rays, they do not have otoliths. Otoliths are made of calcium carbonate, which is the same as limestone, and sometimes scientists actually dig through the poop of seal and anything that eat these kinds of fishes to know that what kind of these animals are eating this fish. Also that otoliths are actually the size of a grain of sand, or if it's a bit bigger, it will be just the size of a fingernail. Besides keeping balance, otoliths also detect the sound around the sea, and as a fact, otoliths also grow every few microns from their birth to death. As we all know, king salmon, which is the largest species of salmon in the world and lives along the entire northern Pacific coast and rivers from northern Japan to central California in the United States. These fish, like all salmon, these salmon are born in a river, migrate to the ocean as juveniles, then return back to the river where they were born to spawn and create a new generation. These salmon spawn only once and then die. When they die, scientists collect their otoliths and retrace their migration pathway and growth over their entire lifetime. From this, we know where does the salmon migrate and how can we preserve these. New information obtained from these otoliths or salmon actually can help us know how we can obstruct these structures like dams. Because today, fishes that are stuck under the dam, the temperature can get hot and then their eggs cannot be fertilized. Humans have been using and modifying rivers for millennials of times to improve our quality of life. Rivers provide many services: irrigation, water supply, fishing, hydropower, maybe ecotourism. And these activities are often carried out at a high environmental cost. River degradation, which fishes move about just to reproduce. So dams are actually essential in our life, but then higher authorities need to actually rethink and maybe provide fish to a passage for fish to move and migrate. We have caused river fragmentation, water quality deterioration, flow regime modification, and habitat modification and destruction, collectively leading to decline of fish stocks. By providing fish passageway, it can actually, at the same time, there's a win-win situation between us and the fish and everything else. Thank you.